Kubernetes and GKE Part 17. This episode has 4 questions. For each question, take a moment to think through your own answer before I share a strong approach. Question 1. What is CNI? Here's a strong way to approach it. CNI, Container Network Interface, is a standard specification used in Kubernetes to define how networking is configured for containers. Pod's core idea. CNI defines how pods get IP addresses and how they communicate with each other in a cluster. It is not a single tool, but a standard plus plugin ecosystem. Why CNI is needed in Kubernetes? Every pod needs a unique IP. Pods must communicate across nodes. Networking must be pluggable. Different vendors. CNI solves this by standardizing how networking is done. How CNI works. High level. When a pod is created, 1. Kubernetes asks the CNI plugin to CNI assigns an IP address to the pod, sets up network routes or bridges. 3. Pod gets network connectivity when a pod is deleted. CNI cleans up networking resources. What CNI plugins do? A CNI plugin is responsible for IP address assignment, network namespace setup, route configuration, pod-to-pod connectivity, sometimes network policies, depending on plugin. Popular CNI plugins: Calico, networking plus security policies; Flannel, simple overlay networking; Cilium, EBF-based advanced networking; WeaveNet, mesh networking. Key characteristics: works at pod networking layer, plugin-based architecture, vendor-neutral, standard required for Kubernetes networking to function. Simple analogy: think of Kubernetes like a city. Pods equals houses, CNI equals electricity plus road system provider. Without CNI, houses exist but cannot communicate. CNI versus Kubeproxy. Important interview point. Feature: CNI Kubeproxy. Purpose: pod networking, IP, connectivity, service routing and load balancing. Level: network setup, traffic forwarding. Scope: pod-to-pod communication, service-to-pod communication. Interview-ready definition: CNI is a specification used by Kubernetes to define how container networking is configured, including IP assignment and connectivity between pods, implemented through pluggable network providers like Calico, Flannel, and Cilium. Nice. Let's continue. Question 2. Explain CSI. Here's a strong way to approach it. CSI, Container Storage Interface, is a standard interface used in Kubernetes to enable external storage systems to be used as persistent storage for pods. Core idea: CSI defines how Kubernetes connects to storage systems, like cloud disks or network storage, in a standardized way. It allows Kubernetes to support any storage provider without changing its core code. Why CSI is needed? Containers are ephemeral. When a pod dies, its data is lost, so Kubernetes needs persistent storage that survives pod restarts. CSI solves this problem. What CSI does? A CSI driver enables Kubernetes to provision storage volumes, dynamically attach volumes to nodes, mount volumes into pods, detach and delete volumes when no longer needed. How CSI works. Flow. When a pod requests storage, 1. Pod requests a persistent volume claim, PVC. 2. Kubernetes calls the CSI driver. 3. CSI driver creates storage, e.g., disk in cloud, attaches it to a node. 4. Volume is mounted into the pod. 5. Pod can read or write data. Key components of CSI. CSI controller plugin handles provisioning, attaching, deleting volumes. CSI node plugin runs on each node, mounts or unmounts volumes to pods. Examples of CSI drivers: AWS EBS CSI driver, Azure Disk CSI driver, Google Persistent Disk CSI driver, Ceph CSI driver, NFS CSI driver. CSI versus old storage model. Before CSI, storage plugins were built into Kubernetes core, in tree, hard to maintain and extend. Now, CSI is out of tree, plugin based, easier to add new storage systems. Key features: dynamic volume provisioning, volume lifecycle management, vendor neutral storage integration, supports block and file storage. Simple analogy: think of Kubernetes like an office. Pods equals employees, CSI equals storage department that gives employees personal lockers, volumes even if employee leaves. Locker data remains. CSI versus CNI. Important interview comparison. Feature: CSI CNI full form container storage interface, container network interface. Purpose: storage for pods, networking for pods, handles volumes, disks, file systems, IPs, networking routes. Example: EBS, NFS, Ceph, Calico, Flannel. Interview-ready definition: CSI is a standardized interface in Kubernetes that allows external storage systems to be integrated as persistent volumes, enabling dynamic provisioning, attachment, and mounting of storage resources to pods in a vendor-neutral way. Great. Moving on. Question 3. What is core DNS? Here's a strong way to approach it. Core DNS is the default DNS service used in Kubernetes to provide service discovery and name resolution inside the cluster core idea. Core DNS allows pods and services to communicate using names instead of IP addresses. Example, instead of 10.96.0.10 you use my service default SVC cluster local Y. Core DNS is needed in Kubernetes. Pod IPs change frequently. Services need stable communication names. Core DNS solves this by mapping service name cluster IP pod endpoints. What core DNS does: 1. Service name resolution resolves Kubernetes service names to cluster IPs. 2. Pod discovery inside cluster helps pods find other services using DNS. 3. Cluster domain management default domain cluster local example DNS format in Kubernetes.